Hello everyone, today we are going to continue our discussion about quadratic equation. In the last class, we discussed about zero product property. That's exactly why we mentioned the method factor works. And also we use the very first method we introduced before is called GCF. Is meaning whenever, for example, when we work on this kind of equation, we take off the common factor out of the terms we work on. For example, this one we know they both have x, so I take it out. And then according to zero product property, whenever we multiply two parts or even multiple parts together to get zero, then one of them must be zero. So that's how do we get to solution. Or sometimes in the future, when we solve polynomials, we are going to have definitely multiple solutions. So today we are going to look at the different example. We're still going to focus on the method factor, but this time we are going to look at a little bit different example. So very first, let's check this example here. So if you check the three terms here, some student might say, can I minus 5 to the other side in order to get this kind of equation solution? I wouldn't suggest to do that because when we look at the square terms here, moving constant term to the other side will not help you to get to the solution. So the first thing we are definitely going to try is to see can we factor. Of course, in the future, I will teach you more method, but today we are going to focus on like can we use factor to try. So as we mentioned, the first thing we always see, do we have a greatest common factor? As you see, they have variables here, they have numbers, but they don't have variables for the last term. And also, if you check numbers here, 6, 5, they do not have like common factor other than 1. So that's why greatest common factor themes cannot help us to simplify any, make it any more easier for us. So this time we are going to say, so factor, as we mentioned, is like a breakdown the two parts. So our goal is to break down these two parts. So that's why we introduce a method called AM method. So you may wonder what does that mean. A stands here for addition. M here stands for multiplication. What does that mean? So that means I'm going to do a little bit puzzle here. I need to find two number to multiply to get this number. And then this the same two number here, I'm going to add them in order to get -6. That's exactly why I mentioned AM, because the position here is a two number I need to get -6, and the two number I need to multiply to get 5. And my suggestion is always starting with multiplication part. So definitely pause here to see if you have solutions, but remember whatever your answer here must to check all the two expression here. Okay, so I believe now you probably have the answer. So some student might say a 1 and 5 that works because 5 times 1 is 5. Yes, that's true, but if we add them, definitely we cannot get -6. So some student might change the idea. Then how about we change all negative? And you are perfectly right. So now both checks. So that's exactly coming from here because right now I'm going to use this two number to help me factor. For x squared, I'm going to break down x times x. For the numbers, I'm going to -1 minus 5 equal to 0. So you may wonder, how does that work? That's actually coming from FOIL. Remember, first, outer, inner, and the last. So if you remember, x times x is x squared. -1x and -5x, we combine like terms, you are going to get -6x. And -1 times -5, this is 5. So that's why in the middle part, since we combine like terms, you're talking about adding. And the last two terms here, you multiply. So that's how we make it happen. That's called factor 2. Now we have two expression. Remember, whenever you multiply two parts to get 0, one of them must be 0. So that's why we are looking at two possible solutions. And we just need to solve them like a regular equation. Now I have this and this. I wouldn't say and because x cannot be the different number at the same time, but we are looking at the possible two solutions here. So if we graph, you can imagine we are going to have one is 1 here, the other one is going to be 5. So that's our solution. So that's one part I want to share with you about factor. This time we do not use GCF, but we still can break down the three terms to this. So next one, we are going to practice two questions here, and we are going to have a quick review regarding this one. Again, I'm going to ask you to pause the video to look at these two questions on your own to see if you can get the answer. So the first one, I'm hoping you are working on the question with me together. So the first one, I whenever see two number here, I want to try if I can factor because definitely there is no other GCF I can take out. So I'm going to try, hey, I'm going to find a two number. Let's write on the side note to get 24. And the other, the same two numbers here, sorry, I'm adding is 11. So some students probably already figure out, hey, I can try, probably someone student want to try, what about 4, 6? But when I try 4, 6 plus them together, it's not going to get 11. So I'm going to give up 4, 6. Let's try another two. So some student probably already check 3, 8. So that's the one we're working. So I'm going to break down x squared to x, then 3, 8, they're all positive. So I just need to put them in the equation. And remember, zero product property tell us I'm looking at two possible solutions. And all I need to do, I just need to solve equation like a regular way. And I'm finally have two possible solutions. You can also double check your solution by putting number back to the original equation. You will definitely get the answer. So this one, some student might say, oh, I do remember this. We mentioned something about GCF. Again, whenever, it doesn't mean you have three terms, you do factor, you have two terms, you GCF, because I want to show you a different, different example here. But for this one, if you look carefully, for 10 and 25, I know they both have 5. And they both have x squared and x. I can take 5x here. And then next part, I just need to check 5x times what give us 10x squared. So 5 times 2 is 10, x times x is going to be x squared. It's like a reverse way to check the distributive property. And 5x times what give us 25x? 5 times 5. Do not forget the negative sign here. And x we already have it, so that's it. Now zero product property tell us whenever I multiply two parts equal to 0, one of them must be 0. So we are looking at two possible solutions. So this one, I just need to solve equation like a regular way. Do not make a mistake. 0 divided by 5 is 0. And this one, so it seems a little bit complicated. Exactly same thing here. So it's going to be 5. Then all I need to do, see, even this is a fraction, but if we solve everything correctly, that's our answer. Okay, so as you can see, we can definitely use different way to factor to get to our solution. But there's one thing I want to remind you. Some student might say, so you are saying 3 terms, I want to try that AM method, and 2 terms, I probably to try GCF. I would say that's not a bad trick, but I want to give you another example. We're looking at the 2 terms, but it seems that if I want to try GCF, I don't see anything common between these 2 terms. So this time it's a little bit confusing. So this time I still gonna try AM method. So you may wonder, the last term is constant, so negative 36, but there is no middle something x, so that means that a we need to add into 0, because compared to this one, I don't have that middle term here. So let's consider that 0. So I'm looking for two numbers. You get to negative 36, and you add them to get to 0. Then what would be the solution? So you can definitely solve this puzzle on your own. And now I'm going to review the answer. I think, I totally believe you probably already get the same answer as mine too. Okay, so now let's break down this as x plus 6, x minus 6 equal to 0. And same thing, we are using exactly the way to solve it. You are definitely are going to get two solutions here. So some student might say, hey, I just want to move 36 to the other side to solve this equation. Is that possible? Yes, you're right. It's possible. But the reason I show this factor, I just want to give you a different perspective to see this is how do we factor this kind of thing. And you pay special attention. I want to use a different color. This is a square term. 36 we know is also perfect square number. So this special part, a square part minus another perfect square number, we have a special name for that, which is called difference. Oh, sorry. Difference of perfect square. Why I give this special name? Because difference of perfect square we can always factor as a positive part and negative part, because that's, if you use FOIL, when you combine this, the middle term will be disappear. So that's why for difference keyword here, do not forget they must be subtracting. If you are talking about adding 36, it's not going to work. Difference of perfect square telling us we can easily to factor this. So some student might say, can I see a different example? Yes, you can. This is a -4, so I can do +2, -2. That's just a special example of this one. This is called difference of perfect square. If you have more questions regarding this one, definitely email me. We can discuss more examples. So that's a part I want to share with you regarding factor. And in the future soon, I'm going to share more methods with you regarding quadratic equation. So that's why quadratic equation is actually very interesting topic, because you have so many methods and can look at the equation from so many different perspectives. I hope this video is helpful. If you have any question regarding this examples, definitely do more practice and email me if you have any questions. Thank you so much for watching this video and study these examples with me together. I hope this video is helpful. See you soon, everyone.